Hello and welcome to this talk. Um, Brief introduction. My name is Julian Fischer. I'm CEO of a company called Any9s. We are building platforms, including Cloud Foundry, Kubernetes, as well as a comprehensive set of data services. So in this talk, we share a bit of the experience that we've collected when working with customers. And the question about when to use Cloud Foundry, when to use Kubernetes, and whether Cloud Foundry environments should be migrated towards a Kubernetes-based stack, and when and how. So the content of this talk is based on experience. I think there are takeaways to share, but also there's a certain amount of opinion in the talk, and therefore, yeah, it's a little disclaimer here. So, as I said, the talk today is about when to choose Cloud Foundry over Kubernetes. So, it doesn't mean that the point is that you should always take Cloud Foundry over Kubernetes, or that Cloud Foundry is a better technology than Kubernetes, or the other way around. The whole point is about, or the whole talk is about, are there organizations with particular situations, and is there a context in which a Cloud Foundry is to be preferred over Kubernetes? When, as this is a simple or a simplifying question to anybody who has followed both technologies, you will immediately grasp that it is you have to narrow down the scope in order to get to an answer. So as we are limited here to 50 minutes, the scope of the question needs to be limited as well. So for example, you can compare Cloud Foundry for Kubernetes with Kubernetes. Then you have to also scope what Kubernetes means. For example, a vanilla Kubernetes versus a commercial flavor of it. You could compare Kubernetes, Cloud Foundry on VMs based on a BOSH deployment with Kubernetes, or you could rather say a Cloud Foundry in general compared to Kubernetes in general. All right. So one of the lessons we have learned recently when talking to our customers who often have large Cloud Foundry environments is that migrating these environments to Kubernetes is surprisingly hard. In several cases, we've even seen that the initial ideas around migrating away from Cloud Foundry that these migration projects have even been stopped. And this doesn't tell a negative story about Kubernetes, and this is not what this here is about. It is more about the question, why do these migration projects turn out to be much harder than initially anticipated? And what are the underlying learnings? Where does Cloud Foundry have, or has maybe advantages in a particular niche over a more flexible technology such as Kubernetes? So one of the first, let's say, comparisons, or the first part of scoping the talk would be thinking about how platform environments are structured. So in the terminology, the term platform environment, we use the term in the following way. So a customer account, usually there are several Cloud Foundry environments. These Cloud Foundry environments, they are usually located in either one or several regions. So from terminology perspective, we talk about a platform landscape, which comprises all the platform environments across all the regions. Within a region, there can be one or several platform environments. The question about a centralized versus a decentralized platform is therefore, how does the structure of platform environments look like? So if you think about a global organization, it is often the case that you have not only one infrastructure, but several of them. So the landscape splits into several regions, and each region can be within or offered by a different infrastructure provider. So for example, you could be on Ali Cloud in China, you could be on Azure in Europe, and on AWS in the US. Just to give you an example. In each of these regions, there will be one of several environments, and these environments, they, for example, can be rather large. If we start with, for example, the idea that there's an organization that has bought into Cloud Foundry a few years back, and which has successfully adapted Cloud Foundry as a technology so that the internal or a third, publicly facing Cloud Foundry environments have been adapted well. These environments often have hundreds or thousands of organizations and thousands to 10,000s of applications of various complexities. So sometimes we have customers, for example, where environments do have a large number of clients. The clients, it can be rather small, but there could also be certain applications that are, let's say, being heavily used, and therefore have a lot of data and a very high availability options. In other cases, a Cloud Foundry environment could be used, for example, by a client internally, where, for example, business units will be represented as Cloud Foundry organizations, and applications could be, let's say, lower in number compared to a publicly facing platform as a service, but maybe more intense in the way these applications are used. So the point here is, if we talk about a Cloud Foundry environment, the common case, at least that we have seen, is that these environments, they are often meant to be a unified application developer stack that will be offered to engineers and developers with the idea to provide them an environment to create applications quickly in an on-demand self-service, to choose data services, and then focus on the actual problem, the actual domain problem, so to say. So Cloud Foundry represents such a unified stack. You can basically download a Cloud Foundry. Cloud Foundry releases have been tested, and Cloud Foundry as a technology is rather comprehensive. It gives you basically all the credentials, all the essential building blocks to create an application developer platform. And this includes aspects such as user management, authentication, and tenant isolation. So Cloud Foundry comes with a UAA service that can be integrated with a given identity provider. It will then create users and authenticate them within the Cloud Foundry system. So, for example, if you create an application developer and you want to deploy an application, Cloud Foundry will check whether this user is allowed to do so. And more than that, you also have a strong tenant isolation, which means that one Cloud Foundry organization is shielded from another organization in various ways and in a solid way. In fact, it's solid enough that Cloud Foundry can be used for publicly facing platform as a service offerings where there is no trust relationship among the tenants. More than that, you have a central marketplace. So if a Cloud Foundry environment is presented to a Cloud Foundry or is presented to developers, these developers, they can push their applications, but they can also choose from service brokers that have been configured with that particular Cloud Foundry. And this gives organizations the opportunity to make a selection which data services, for example, are to be used and how the lifecycle of these data services are managed, which enables central governance around the quality of data service automation. So, for example, customers in finance, they often have very strict requirements how the data is to be treated. Their selection of, let's say, for example, relational databases and their automations is a challenging task. They often run a lot of tests. They'll have to check whether a solution is compatible with their internal policies. So, for example, are backups stored, in a different region? Is it possible to recover from network segmentations properly, and so on? And with a Cloud Foundry and its central marketplace, it is possible to establish such a governance model without much effort. And that is one of the advantages that Cloud Foundry has over Kubernetes, which does not come with such a marketplace by default. You can add it, and that's one of the, let's say, repeating objectives you could have to arguments presented in this talk as well. I can actually add a particular functionality to Kubernetes. And yes, it is possible to do that. And I also think that's meaningful and wonderful. But it comes with cost. And, that involves, for example, that a Cloud Foundry as a whole comprehensive, let's say, technology that can be used to create turnkey application developer platforms is well tested and integrated. So, for example, the user management works with a cloud controller, works with a marketplace in a very well established way. If I were to build a Kubernetes-based stack that imitates the functionality, that wouldn't be, that would be possible given the Kubernetes extensions there are in the market. However, building such a stack also represents additional effort, and there must be integration tests that ensure that not only a particular point in time the stack is working, but also along managing the life cycle of all these individual pieces as they may be changed by their individual manufacturers or open source communities, that I choose a particular set that is compatible to each other and ship that as releases. And this represents additional effort. Also, the scope is now restricted to Cloud Foundry on virtual machines, assuming that BOSH is being used, which is the standard, the prime standard of Cloud Foundry environments. The larger environments that we see, they all rely on Cloud Foundry and BOSH based deployments. And the reason for that is, among others, first could be that the technology in a particular customer account has been adopted a while ago where there was no alternative to BOSH, but also because BOSH is a rock solid foundation for creating Cloud Foundry environments. And it is very predictable and works at large scale. So we run customer environments with thousands of virtual machines, and it works like charm. So once a team has managed to run Cloud Foundry using BOSH, the operational model is consistent and works across infrastructures because BOSH has true abstraction from the underlying infrastructures. All major infrastructures are supported. And this means that one team being familiar with BOSH-based operations can operate Cloud Foundry platforms across infrastructure seamlessly. The amount of adoption in the way, let's say, the CI/CD tooling when exploring a new infrastructure is rather low. Now, again, you could argue that in Kubernetes, this is also the case. You can get a Kubernetes on any infrastructure, on-premise as well as on public infrastructures. And that's true. However, the question would be, what's the tooling that abstracts the way these clusters are being created? There are tools such as COPS. There are tools such as Cluster API. There are tools that are specific to the particular infrastructure as, for example, offered by the infrastructure vendors themselves. And while it is possible to create Kubernetes clusters on all of these different infrastructures, the question is how much or how well does this abstraction hide the differences of the underlying infrastructure? In our own experience, not as much as BOSH. And therefore, additional complexity is added to operating Kubernetes clusters across infrastructures. Well, it is absolutely possible, but it does not have the same economy of scale, and it does not have the same economy across infrastructure providers. Is this going to be the case always? Well, I don't think so. I think all these technologies will evolve, and at some point we may have to reevaluate. But for now, true infrastructure agnosticism and the way, for example, our operation teams operate Cloud Foundries across infrastructures, we couldn't operate the same platforms based on Kubernetes technology with the same sized teams. At least not without. No, it's basically that. Because if we want to build a stack that can be operated as efficiently, we'd have to add more effort in testing and integrating such a stack. So that basically makes the statement true. So a key ingredient to Cloud Foundry's ability to work at scale to this point is BOSH, because I can point BOSH to major infrastructures and it will deploy what I want. If I deploy Cloud Foundry on Kubernetes, for example, which is also an interesting option, especially for the future, the question would be, where do I get my Kubernetes from and how do I operate my Kubernetes? So the complexity of Cloud Foundry doesn't change when I apply it to Kubernetes. It still requires a cloud controller. It still requires this and that. So the operational complexity of Cloud Foundry itself has a certain, the operation of Cloud Foundry has a certain complexity, and that does not necessarily change, let's say in an order of magnitude, when I put it on Kubernetes. And I still have to operate the Kubernetes cluster. In Cloud Foundry, I usually have either an infrastructure team already when I use BOSH to deploy, or I'm using a managed infrastructure. So the comparison for here would be to have Cloud Foundry run on a managed Kubernetes cluster. I think that would be the closest we can get to somehow eradicate the argument I'm trying to make here that running Cloud Foundry with BOSH for large environments has a better economy of scale compared to Kubernetes. If you have managed Kubernetes, that's low cost, adding little overhead compared to virtual machines, well, that'll somehow mitigate the argument I'm making here. But this is not what we currently observe across the customer accounts we have, because in many cases, Kubernetes clusters aren't set to autopilot, but instead they require a certain amount of attention. So the economy of scale reduces complexity and operational overhead. And I think that's one of the strong sides of Cloud Foundry. In those large environments that we've seen, Cloud Foundry is just a fantastic tooling and it keeps its promises. But if you look at smaller accounts, for example, smaller companies or organizations that are still in early stage adoption where there's not so much demand, the economy of a Kubernetes cluster is much better. So if you have a small team and you want to deploy a couple of applications, you can buy a Kubernetes cluster off the shelf on public infrastructures for a few hundred euros a month, and there you go. If you scale that to thousands of nodes, you'd see different problems. For example, the missing tenant isolation within Kubernetes, at least a tenant isolation that's comparable to the tenant isolation you find in Cloud Foundry, which will create the motivation to create more Kubernetes clusters than you would have Cloud Foundry instances. But we come to that. In this diagram, this assumption is basically visualized. So if you think about a Cloud Foundry, and you split the Cloud Foundry into several organizations, each organization has, its own abilities, the ability to create spaces, the ability to create data service instances and push apps. It's solid enough that one tenant won't see applications from another tenant and that they won't be able to, steal, resources from a different tenant. On scalability-wise, these environments can be, as I said earlier, comprise thousands of virtual machines, and that makes Cloud Foundry very interesting from the perspective of operational overhead, because you have to lifecycle manage only one Cloud Foundry. So once you have a CI/CD tooling, let's say a Concourse pipeline, and a team that has seen the average issues that may come up doing an upgrade, for example, of a Cloud Foundry environment, you should be fine. So even globally operating organizations, they get along with a fistful of environments. Whereas, for example, if you go down the road with Kubernetes and you, for example, have different teams with different needs, there's, I'd say a lot of advantages with that comes with Kubernetes. For example, each team can configure its own cluster in a very custom way. And in fact, this is what sometimes is necessary. So if you, for example, need to run a workload that somehow implicitly assumes a certain version of Kubernetes to be present, or a certain extension that is rather intrusive in the system, then having a dedicated Kubernetes cluster is both advantage insofar that it enables a very high degree of customization, but it's also a disadvantage because it forces the team to take over operational responsibility and manage the lifecycle of a Kubernetes cluster. So even if that's supported with very well written automation, if you look at the simplifying diagram here, you would see that lifecycle managing hundreds of Kubernetes clusters versus maybe a dozen environments for Cloud Foundry is not the same effort. So even with good automation, operating a lot of Kubernetes clusters more work than operating a few Cloud Foundry environments. So this leads to the general question. If you look at a Cloud Foundry environment, an existing Cloud Foundry environment, how many Kubernetes clusters do you have to have relative to the number of Cloud Foundry environments? Well, this is a question that has to be answered in a particular organization's context. But from our experience, the mapping is you need many more clusters of Kubernetes than you would need foundations of Cloud Foundry. So what does this mean? It means for large environments where Cloud Foundry has been used, or the workloads are known to be 12-factor compliant, Cloud Foundry can represent a better economy of scale compared to Kubernetes. That's a statement I would definitely sign. So, to be fair, there are situations where you definitely want to choose Cloud Foundry over Kubernetes. So let's have a few arguments of them, knowing that they are potentially not all the arguments there are. So if you prefer container images and pods over the CF push experience, well, that's definitely an argument to get a Kubernetes cluster instead of a Cloud Foundry installation. So why would you prefer container images and pods? Now, not only because it's popular, but for example, a Kubernetes in a Kubernetes cluster, each pod gets its own IP address. So the idea of having IP addresses per pod means that if you have applications that currently run within a virtual machine, where each virtual machine usually also has its own IP address and is able to use all the pods, that you can basically transfer that application into a pod as well, because the pod has its own IP address, and each pod can use all the available ports, just like you would be able to when using a virtual machine. So long story short, The concept of a pod in Kubernetes is much better suited to move and migrate workloads from a virtual machine to a container than it would be with Cloud Foundry, where you'd have to stick with a 12-factor manifest, which poses which creates a lot of restrictions that the application developer has to deal with. So that's one of the situations where you rather go with a Kubernetes cluster. And also, if you have teams, and these teams they have particular problems, and that these problems naturally involve, for example, create dependencies to libraries that, for example, like you want to have a workflow manager, or you want to have certain machine learning libraries that exist as Kubernetes extensions. Then in this case, assembling a Kubernetes cluster that represents, let's say, a small platform for a group of developers that's very highly customized, that's exactly where Kubernetes is awesome at, and where Kubernetes should be preferred before trying to force a rectangular shaped application into a triangled Cloud Foundry. Just go with Kubernetes, and you'd be much happier. And last but not least, Kubernetes is a cool thing. So if you definitely want Kubernetes, maybe you should go with it and make your own experience. So let's sum it up. You should choose Cloud Foundry over Kubernetes if you already have a large Cloud Foundry environment and it works. If your organization is used to Cloud Foundry, you have, created automation within your development processes against the Cloud Foundry API or the Cloud Foundry CLI, that's basically no urgent need to change it. And our experience is that when clients try to move away, they found it to be more complicated than initially anticipated. So make your research and your own cost benefit analysis of that before you head into such a migration project with too much enthusiasm. The majority of workloads, the majority of your workloads are 12-factor compliant, as I said, so that the CF push experience provides a smooth way to get code up and running. That's also a reason to get a Cloud Foundry. So along with the marketplace and the CF push experience, developers really don't have to have so much operational responsibilities. In every case, you build it, you run it is the regular operational paradigm of these days. But with the Cloud Foundry environment and its high degree of on-demand self-service focus, application developers, as long as their applications fit well into the model, there's barely any experience that's more pleasant than a CF push on a Cloud Foundry. If platform environments tend to be large, thousands of applications, even thousands of tenants, then Cloud Foundry represents a very solid choice. So if you're looking for a centralized application development platform and you don't want to have many different Kubernetes clusters because you anticipate that with that great power, the responsibility.
With great power comes great responsibility.
Will become a problem where developers maybe don't have the time or the competencies, the skills to manage such a Kubernetes cluster beside of the application workloads. A Cloud Foundry will be for you. If you want to enable on-demand self-service for app developers, well, to some degree you can do that with Cloud Foundry and with Kubernetes. But here the idea is the combination of let's say the governance that comes with Cloud Foundry. For example, you can pre-select the build packs and quality assure them according to the security policies of your organization. Having a central marketplace with proper data service automation where the products have been pre-selected and checked by data service experts within your organization. All these things are good advantages of Cloud Foundry. Yes, you can use build packs with Kubernetes. Yes, you can have pre-selected operators with Kubernetes too. But I think it's more complicated than with Cloud Foundry. And I know this can be discussed in a dialectical way. So please feel free to engage with me after the talk and let's have a few arguments about this. Happy to learn from your opinions too. So freeing developers from operational tasks as much as possible is also a reason why you could go for a Cloud Foundry. As I elaborated before, managing a Kubernetes cluster, even if you take a very mature off-the-shelf product, is overhead. And because there will be more Kubernetes clusters than Cloud Foundry environments, there will be more operational overhead across teams. So unless you really need that flexibility, this additional operational overhead may become a disadvantage as it represents waste in the lean interpretation of the word. If you want to have a centralized application development platform with a central marketplace, that's the reasons we briefly mentioned. And last but not least, the infrastructure agnosticism. Here, I'm referring to Cloud Foundry for VMs, especially because BOSH is such an underrated piece of technology. It may not be very welcoming in looking at it after a long day in the business and, downloading Cloud Foundry and setting up a Cloud Foundry environment with BOSH in 10 minutes. But for platforms that are larger, where you really have the ability to train up a team or, hire an expert team or anything, at a certain size, there's a break-even point where the economy of scale of Cloud Foundry kicks in and Cloud Foundry becomes a major advantage. So when do you choose Kubernetes over Cloud Foundry? Well, first of all, if you want to install Cloud Foundry for Kubernetes, well, then you obviously also have to go for Kubernetes. So that's one of the reasons. You're not really choosing Kubernetes over Cloud Foundry in this case, but, you get the point. There are many stateful and non-12-factor compliant legacy apps to operate. That's an advantage for Kubernetes. And if there are many VM-based workloads that you want to migrate to containers, also a good argument for Kubernetes. If you have dependencies within your application towards extensions to Kubernetes that exist, for example, particular service mesh functionality, workflow managers, or machine learning libraries, well, then definitely Cloud Foundry is more restrictive and Kubernetes would be the way to go. And workloads that are already in Kubernetes format because you took it off the shelf or the vendor basically provided it to you in that way, then Kubernetes is also a good choice. In general, if you want to customize your application developer platform, let's say to a particular niche, then Kubernetes is for you. It comes with additional effort and responsibility, but if your team is capable of doing so, why not use Kubernetes? So I hope this talk helped you to get a better sense of when to choose what. We at Any9s, we embrace Kubernetes to a maximum degree, and we also see how well it fits into a large scope of applications of different scenarios. And so this is not selling against Kubernetes, but we can also see that some Cloud Foundry environments, they will stay much longer than initially anticipated because of these benefits Cloud Foundry has. So, I hope you enjoyed the talk. Long story short, large Cloud Foundry environments, they have a significant and a very outstanding economy of scale. That economy of scale does not necessarily exist for BOSH-based installations that are very small. The Cloud Foundry for Kubernetes somehow mitigates that, so you can start much smaller compared to BOSH-based installations. But the overhead of a Cloud Foundry compared to a bare Kubernetes cluster is larger, and a Kubernetes cluster for small environments has a better economy than Cloud Foundry. For large environments where predominantly 12-factor apps are being run, Cloud Foundry has advantages. You may want to look at it. Well, thank you a lot. If you have questions, reach out to me after the talk or via social media. I'll be happy to chat. Thanks a lot.